Tutorial number 11, question number 1. The uniform cylinder bar of mass m pivots freely around the horizontal axis around O. If the bar is released from rest in the horizontal position show where the spring is unstretched, it is observed to rotate a maximum of 30 degrees clockwise. We need to determine the mass m of the bar as well as the magnitude of angular velocity of the bar when the angular displacement is 15 degrees clockwise from the released position. First, question number A, we could say the energy is conservative during this whole period. Then we have T1 plus V1 is equal to T2 plus V2. The bar starts from rest, then T1 is equal to 0. When it's reached 30 degrees clockwise, then the velocity of the bar should be 0 because it's reached its maximum, then T2 is equal to 0. If we say this is our reference, then V1 is also equal to 0. Then we have 0 is equal to negative mgh plus 1 over 2 ks squared. S right here is the stretch of the spring. Then we can draw a brief diagram right here. Here's our theta. Here's A. We can also call this D. Here's the center of gravity. So this is H. So we can say H is equal to 1 over 2 B sine theta. We can solve the S by plus all the vectors right here. Then RDO plus ROA plus RAC plus RCD is equal to 0. So RDO is equal to negative 1 over 4 BJ plus 3 over 4 B cosine theta I minus 3 over 4 B sine theta J plus RAC plus negative 3 over 4 BI. This is equal to 0. Then we have RAC is equal to B 3 over 4 minus 3 over 4 cosine theta I plus B 1 over 4 plus 3 over 4 sine theta J. Then we need to get the magnitude of this vector. Then RAC is equal to square root B squared 3 over 4 minus 3 over 4 cosine theta squared plus B squared 1 over 4 plus 3 over 4 sine theta squared. So this is equal to 1 over 4 B square root 6 sine theta minus 18 cosine theta plus 19. Then S is equal to RAC minus 1 over 4 B. Then when theta is equal to 30 degrees, B is equal to 0.2 meter. Then S, which is the stretch, is equal to 0.0766 meter. And H is equal to 1 over 2 times 0.2 times 1 over 2. This is 0.05 meter. If we put S and H back to our equation, we will have M is equal to Ks squared over 2GH. This is equal to 1.197 kilogram. Here's our question A. For question B, we should change our theta to 15 degrees. Then we have our new stretch. Just put it into our equation. For S is equal to 0.08 89 minus 0.05. This is equal to 0.039 meter. The what's difference right here is when the bar is 15 degrees clockwise, it still has the velocity. So T2 right here will not be 0. Then we have T3 is equal to 1 over 2 IO omega square. IG is equal to 1 over 12 MB square. Right here is it's a bar rotated around its gravity center. We need to transfer it back to pivot, which is O. Then IO is equal to IG plus MD square. This is equal to 1 over 12 MB square plus MB over 2 square. This is equal to 1 over 3 MB square. This is equal to 0.01596 kilograms times m square. At this time, H3 will be 1 over 2 B sine 50 degrees. This is equal to 0.026 meter. Then T1 plus V3 is equal to T1 plus, oh, my bad. T1 plus V1 is equal to T3 plus V3. Then again, this one is not equal to 0. Then T1 is equal to 0. V1 is equal to 0. So we have 0 is equal to negative mgh3 plus 1 over 2 IO omega square plus 1 over 2 ks3 square. Then omega is equal to 4.36 radian per second. Question number 2. The center of 200-pound wheel with centroidal ratios of gyration of 4 inches have a velocity of 2 feet per second down the incline in the position shown. We need to calculate the normal reaction force under the wheel as it rolls past position A. As we can see that the energy is conserved during this period, then the change of gravitational energy plus change of kinetic energy is equal to 0. And delta Vg is equal to negative mgh. So it can be shown in the diagram that this length is our h. So we could say delta Vg is equal to negative 200 times 12 over 12 sine 30 degrees plus 18 over 12 1 minus cosine 30 degrees. This is equal to negative 140.2 feet per times pound. Delta T is equal to 1 over 2 IC omega 2 square minus omega 1 square. IC is equal to 200 over 32.2 times 4 over 12 square plus 6 over 12 square. This is equal to 2.24 second square. Then omega 1 is equal to 2 over 6 over 12. This is equal to 4 radian per second. And omega 2 is equal to V over 6 over 12. This is equal to 2V. Delta T is equal to 1 over 2, 2.24 4v square minus 4 square. This is equal to 4.49 v square minus 17.94 feet times pound. Then 0 is equal to negative 140.2 plus 4.49 v squared minus 17.94. Then we will have v squared is equal to 35.3 and v is equal to 5.94 feet per second. So as we can know that acceleration in normal direction is equal to v squared divided by r. Then we also have the Newton's second law, which is Fn is equal to man. Then we can get n minus 200 is equal to 200 over 32.2 times 35.3 over 18 over 12. This is equal to, then we can get n is equal to 346 pounds. Question number 3. A planetary gale system is shown. If the torque of 5 Nm is applied to the shaft of the spider at O, we need to determine the magnitude of the initial angular acceleration of the spider. First, we can get the displacement of the point P. Then delt dsp is equal to capital R minus R times d theta. And d theta A, which is the change of the angle of the gale A, is equal to dsp over r. This is equal to capital R over r minus 1 times d theta. Vp is equal to r minus r times theta dot. Omega A is equal to Vp over r. This is equal to r over r minus 1 times theta dot. Then the acceleration of the point P is equal to r minus r times angular acceleration. The angular acceleration at the point A is equal to ap t over r. This is equal to r over r minus 1 times alpha. Then du is equal to dt spider plus dt gales. And du is also equal to n d theta. Then dt spider is equal to d 1 over 2 io omega square. This is equal to io omega d omega. This is equal to io alpha d theta. dt gales is equal to 3 d 1 over 2 ia omega a square plus d 1 over 2 ma vp square. This is equal to 3 ia alpha a d theta a plus ma ap t times dsp. This is equal to 3r minus r square times ia over r square plus ma alpha d theta. So m d theta is equal to io plus 3r minus r square times ia over r square plus ma times alpha d theta. Then 5 is equal to 1.2 times 0.06 square plus 3 times 0.15 minus 0.05 square times 0.8 times 0.03 square over 0.05 square plus 0.8 times alpha. Then alpha is equal to 135.3 radian per second square.